Right. So let's start. Do you guys have any questions about the material that we've covered so far? Any questions about the homework? Or should I just get going? All right. So we were discussing how to construct the SQL queries, right? So we talked about this notion of a select from where template that allows you to ask fairly complex queries on data, right? So the select from where syntax basically allows you to list. I mean, the way to read this would be you start from the from, which lists a bunch of relations. Then number 2 is you look at the where, which has a bunch of conditions, and then from among all of the tuple combinations that satisfy, you select or you decide on which attributes you want to be part of the output, right? So the way to read this is from to where and then to the select. Okay, so that's the way to read these queries. We talked about this particular example where I start from taking all of these 3 relations, listing them in the from clause. Then I have a where clause where I connect the person.name to purchase.buyer. So essentially doing a natural join of sorts, or a theta or a equijoin between person and purchase. And then purchase.product is product.name, again doing an equijoin between purchase and product. And then finally selecting the category of products that I care about. So product.category is equal to telephony. Okay, so that was the flow of this, and this is a query that involves multiple relations, as we saw earlier, right? And the operational semantics, like I mentioned, for these multiple relation queries is you start from the cross product of all of the relations in the from clause. That's step 1. Step 2 is apply the selection condition from the where clause. And step 3 is you project onto the list of attributes and expressions in the select clause. Okay, so it's you start with the cross product, you apply the selection condition, and then you subselect the set of attributes and expressions in the select clause. So in some cases, you may want to use multiple copies of the same relation, especially if you're, for instance, doing a self join. So if you want to relate some information in a relation with itself. And the way to do this is to simply list multiple copies of your relation using a tuple variable. Okay, so this is just a way to refer to these relations in the from clause. So let's consider this example. So let's say I have this select from where query where I said I want to select s1.bar from cells s1. So cells is being renamed as s1 and cells s2. So cells is being renamed also as s2, where s1.beer is equal to s2.beer and s1.price is less than s2.price. So any guesses on what this query might translate to? Yep.
You're finding the bar that has like the lower price for a certain beer. Does that make sense?
Maybe a different answer than that? Yep. Selling the same beer at 2 different prices. That's exactly right. So basically, you're finding the bars such that there is the same beer in both of the bars, but okay. So hang on. Let me try to recollect what was going on here. So I want to find s1.bar such that. Okay, so this doesn't quite translate to what you said either, right? So what did you say again?
That the same bar is
Okay, so that would be true if I added an additional condition which was S1 dot bar is equal to S2 dot bar, right? Without that, would it still hold? No. Okay. So what does this evaluate to? Now I'm confused myself. Any questions or any suggestions? So this query doesn't quite make sense, because in some sense you are selecting the bars such that there are two beers, or there is a beer that's sold by two different bars with two different prices. That's probably not a very interesting query. So this would make more sense if I had this AND clause with S1 dot bar is equal to S2 dot bar, in which case what she said was absolutely correct, which is that these are the bars that sell the same beer at two different prices. I'm not sure what you said was correct either, for either interpretation, but I'm not sure what you said. Okay. Anyway, yes?
So you say it's the bars,
Yeah.
but what's the first line do then? So that's S1 dot bar.
So the way to think about this is the way to reason about a query is you always think about the from clause first. The from clause is taking these two relations and doing a cross product. Okay? So you have two copies of the same relation, you're doing a cross product. And then you apply the where condition to subselect some of the combinations of tuples. And then finally the select condition throws away all of the attributes that you don't need in the output. So basically what you okay, so let's work through what you get, right? So S1 has bar, beer, price. S2 has bar, beer, price. Right? So those are the three attributes for S1 and S2. And then I've gone and in the where clause I've said S1 dot beer is equal to S2 dot beer, and S1 dot price is less than S2 dot price. Right? If instead of S1 dot bar I had listed star, I would have 6 attributes, right? I would have S1 dot bar, S1 dot beer, S1 dot price, S2 dot bar, S2 dot beer, S2 dot price as my 6 attributes that are output. By only selecting S1 dot bar, what I'm saying is project onto just this attribute, throw away everything else. Okay? So that's what that means. Any questions about this? Yes, this query didn't evaluate to anything interesting, but hopefully you at least understand how to read a SQL query of this form. Any questions about any of this? Okay. Oops. All right. Right. So like I said, given a select from where query, the translation to relational algebra is to think about starting from the from clause and doing a cross product of the relations listed in the from clause. So you're doing cross product between R1, R2, all the way up until Rn. And then you are selecting the tuple combinations that satisfy the conditions listed in the where clause. And then you're projecting onto the attributes that are listed in the select clause, right? So these attributes. So select from where queries are essentially join, select, project, or cross product, select, project queries. Okay? So essentially you start with the cross product, you apply a selection condition, you apply a projection operation. That's what these select from queries mean. Any questions about how to read these queries? Any other questions about the meaning? All good? Okay. So another convenient way to think about the select from where queries is by thinking of them as nested loops. Okay, so so the way to think about this is you have a set of tuples that you're going to be outputting. Let's call that the answer. So you start with the answer being an empty set, and then you initialize a loop for every single one of your relations. So you initialize one variable corresponding to R1, one corresponding to R2, one corresponding to Rn, such that that variable takes on the value of a tuple in the corresponding relation. Okay, so for every tuple in R1, for every tuple in R2, for every tuple in R3, all the way up until every tuple in Rn, I do something. And what is that something? So I first check if the conditions is satisfied. So I first check if the combination of tuples satisfies the condition. And then if it does satisfy the conditions, then the answer gets expanded. You add a tuple to the answer, but in the answer you only subselect the attributes that are listed in the select clause. So you only subselect A1 through AK of all attributes that are relevant in these tuples. Okay, so basically you have one tuple corresponding to x1, one corresponding to x2, all the way up until xn. You first check if this combination of tuples satisfies the conditions, and then if it satisfies the conditions, then you subselect the set of attributes from these tuples, and then you add that as part of the answer. And then you keep doing this for every combination of tuples. Is this clear? So this is another interpretation of what these select from where statements actually do. Any questions about this? All good?
So the handling the computational complexity is very expensive?
Yes. So in this particular case, even without this, the computational complexity, or if you have a large number of relations listed in the from clause, it could end up being a very costly operation. Right? So certainly this could be fairly expensive if you have, let's say, 20 different relations listed in the from clause. Okay, so but at the same time, even though I've logically told you this is the order in which these tuples are evaluated, there are convenient ways to reduce the amount of computation. Okay, for instance, let's say there was a condition in the where clause which said R1 dot ID is equal to 100. Okay, so that essentially means that, and let's say ID was a primary key for R1. So if R1 dot ID is equal to 100, then there is a single tuple in R1 that's relevant for this query. So I can actually apply that condition to R1 first, subselect just that one tuple, and then join it with the rest. So even though logically I'm telling you that this is how you read it, this may not be how the database actually executes it. It might execute it in a completely different way. That might be more efficient. Make sense? Any other questions about this? Okay. All right, so this is another exercise for you guys if you're interested. It's very similar to the previous query that we talked about, so this should be straightforward. Okay, so this is, now we are moving on to the notion of subqueries. Subqueries offers a substantial power that is not in a sort of, or substantial convenience that's not in relational algebra. It does not add to substantial power. Okay, so it adds to substantial convenience. And so let's talk about what these subqueries do. So a subquery is nothing but a parenthesized select from where statement which can be used as a value at various places. Okay, so it's like you have this select from where statement, and then within the where clause you might end up having another select from where statement. So you're using the result of a select from where statement as a value in this case. Okay, so how do we, so this is one option. So you list it within the where clause. Another option is to have it within the from clause, right? So this, since a parenthesized expression evaluates to a value or a set of values, you can treat it as a set. You can use it at various places in your query. So you can basically, in some sense, recursively have many select from where statements within a nested format. So let's start with the simplest form of a subquery. The simplest form of a subquery is one that returns a single value, a single scalar value. So, and when would this be the case? So this would be the case, for instance, if you have a functional dependency that holds, and because of that, the result of a select from where statement ends up being a single value, right? So for instance, if I want to find the name of a student with ID is equal to whatever, then that would be a single value that is returned as a result of a select from where query. So this single tuple is often guaranteed by a key constraint, and if this ends up being no tuple or more than one tuple, then this ends up being a runtime error. Okay, so that's the background. Let's see how you can actually use this. So let's start with a simple example. So let's say I have a relation called cells. I want to find the bars that serve Miller for the same price that Joe charges for Bud. Okay, so Joe is the name of a bar, by the way. So Joe charges for Bud. I want to find the bars that serve Miller for the same price that Joe charges for Bud. So this is a case where two queries will probably work and will probably be very convenient to write. So the first query is basically you sub-select the value for the price that Joe charges for Bud, and then you find the bars that serve Miller at the same price. So let V1 be equal to the price that Joe charges for Bud, and then you use that V1 in the second query to find the bars that sell Miller at the same price. So instead of two queries, let's talk first about how you would do it with one select from where query with no subqueries. Okay, so what we've learnt about so far, let's try to use that to see how easy it is to do it and how subqueries makes your life simpler. Okay, so any guesses on how you would use what we've learned so far, the select from where construct, to answer this question? So from cells, I want to find the bars that serve Miller for the same price that Joe charges for Bud. So how would I do this with what I've learned so far? Any guesses? Yes.
Say from cells, select price where bar equals Joe and Q equals Bud.
Right. So if I wanted to find the answer to this, what you said is absolutely right. I'm looking for one single query that gives me the answer to this, rather than two separate queries. If I wanted one single select from where query to answer this question, how would I do this? So let's start with the from clause. Okay. So I have one relation which is called cells. I can certainly list cells in the from clause, right? Is that sufficient? So once again, I'm looking for a single select from where query that answers this question. Yep.
In the from clause, do you need to rename cells and create two different relations to them?
Yeah, exactly. So in the from clause, you would need to rename cells and create two different relations or two different copies of cells. And why is that?
Because you're comparing two
Correct. So you're comparing two different values that are in the same relation, or you're comparing two different tuples in the same relation, because you want to find the bars that serve Miller and the ones that serve, and the price that Joe charges for Bud. These are two separate tuples in that relation. In order to be able to make this comparison, I need two different copies of cells, right? So I would start with, let me write it here, from cells S1, cells S2. Okay, so that's good. So we have the first step done. So you have from. What about the where? Anyone? Yep.
Would it be S1 dot bar equals Joe,
Shh.
S1 dot beer equals Bud, and S2 dot beer equals Miller, and S1 dot price equals S2 dot price?
You want to do it a little slower? Okay, so S1 dot bar is equal to Joe. Good.
S1 dot beer equals Bud,
Yep.
S2 dot beer equals Miller, and S1 dot price equals S2 dot price?
Absolutely. And S2 dot beer equals Miller, and S1 dot price is equal to S2 dot price. Okay, so does this make sense to you all? If there's someone this doesn't make sense to, raise your hand now. So why, I'll give you a short explanation. Why does this make sense? Well, what he suggested was, let me use S1 to refer to the tuple corresponding to the Joe Bud tuple, or the prices that, or the price that Joe charges for Bud, and S2 refer to the Miller tuples. Okay, so in doing so, in order to ensure that he has S1 dot bar is equal to Joe and S1 dot beer is equal to Bud. So this allows you to subselect the tuple within S1 that is about Joe and Bud. Then for S2 you have S2 dot beer is equal to Miller. So these are the tuples within S2 that are pertaining to the beer Miller, and then I want to connect these two because I want to ensure that they are talking about the same price. So S1 dot price is equal to S2 dot price. Okay, so once I'm done with that, basically I have connected the two tuples and I have ensured that I have what I need in order to compose my select. The select is simply, what is the select? Yep. S2 dot bar. Yep. S2 dot bar. Perfect. Okay, so so you're subselecting the bars that serve Miller at the same price as Joe charges for Bud, right? So S2 refers to those bars, S1 refers to the Joe Bud tuple. Any questions about this? Good to go? Okay, so as we saw here, we had to do these somewhat elaborate theatrics to get this to work. There are lots of these AND clauses. So how do we make it simpler with subqueries? Okay, so this gives you a nice sort of motivation for why subqueries actually helps. So the subquery is actually very intuitive. The subquery basically says, select bar from cells where the beer is Miller and the price equals the price that Joe charges for Bud. Right? So, so this was corresponding to our S2 relation in the previous example. This was corresponding to our S1 relation in the previous example. So our S1 and S2 copies. So once again, I have my external select from where, which is select bar from cells where beer is equal to Miller and price is equal to the price that Joe charges for Bud. So that is what this nested subquery capture. So this is select price from cells where bar is equal to Joe bar and beer is equal to Bud. Any questions about this? So as you can see, this is a lot more convenient because you don't join multiple, or you don't do a cross product of multiple relations at once. You focus on one relation and then you do the implicit checking of a condition that involves multiple relations within the where clause, within the subquery. Okay? Is this good? Okay. So far we talked about this single scalar value, right? So this is a single value. If, for instance, this relation ended up giving two different prices, then this would lead to a runtime error because you're comparing it to a variable, right? So this would lead to a runtime error. Or if it didn't return a price, again it would lead to a runtime error. So this query only makes sense if this subquery leads to a single value, a single scalar value. Now, turns out you can use subqueries even when it doesn't return a single scalar value. For that, you have more interesting operators like the in operator. Okay, so the in operator basically says, or the use of the in operator is as tuple in relation. Okay, and this condition tuple in relation is true if and only if the tuple is a member of the relation. Similarly, tuple not in relation means the opposite. So these in expressions can appear in the where clause, and the relation is often a subquery. Okay, so let's see an example. So here I want to find from beers, which contain name and manufacturer, and likes, which contains customer and beer. I want to find the name and the manufacturer of each beer that Fred likes. Okay? So without using subqueries, again, let's think about how we would do this. How would we do this? Looking for a high-level explanation as opposed to the details. So I have two relations, one corresponding to name and manufacturer, and the other corresponding to customer and beer. So customer likes a particular beer, and I want to find the name and the manufacturer of each beer that a specific customer likes. How would I do that? This is similar to the previous query that we talked about. Let's talk about how we would do this without subqueries first. What would be in the from clause? Anyone? Yep. Beers and likes. Yeah, so beers and likes would be in the from clause, right? So you're implicitly doing a cross product of beers and likes, and then in the where clause, you would end up checking whether the likes tuples that you're focusing on are talking about Fred, and then you would be doing a equality condition between likes.beer and beer.name, and then in the select clause, you would be selecting the name and manufacturer. Okay, that's it. It's a pretty straightforward query. I can write it down. So you have from beers and likes, where beers dot name equals likes dot beer and likes dot customer equals Fred. Okay, and then the select would simply be beers dot name and beers dot manufacturer. Okay, it's a pretty straightforward query. It's not super complicated. But the subquery makes it even simpler, right? So the subquery basically allows you to say select star from beers where name in the set of beers that Fred likes. So select star from beers. So once again, I want the name and manufacturer of each beer that Fred likes. So from beers where the beer is in the set of beers that Fred likes. So this subquery basically selects the beers from likes where customer is equal to Fred. Okay? So this is how I would replace this more complex query with a subquery. Okay. So this was the in operator that allowed you to operate on sets. A different type of operation on sets is the exists operator. The exists operator basically operates on a relation. This exists operator evaluates to true if and only if the relation is non-empty. Once again, like the in operator, the exists operator can appear in where clauses. So let's say I have once again my beers relation, and I want to find the beers that are the only beer by their manufacturer. And once again, for every one of these queries, you can think about how you would possibly do it without using subqueries. This will force you to solidify your understanding of the basic select from where, okay? But I'm not going to do it for this one. So for this one, let's talk about how I would do it with a subquery. So once again, I want to find all of the beers that are the only beer by their manufacturer. Okay, so there are no other beers that are made by the same manufacturer. So the first part of this is pretty straightforward. Okay, so I want to select the name from beers. So I want basically this part of it is straightforward. So if you ignore everything below this, I want to select the name from beers. Okay, where there does not exist. So once again, I'm using the not exist not exist keyword. Another beer by the same manufacturer. Okay, that's what this subquery actually means. So this is the set of beers with the same manufacturer as B1 but not the same beer. So how do I check that? So it's select star from beers where manufacturer is B1.manufacturer and name is not equal to B1.name. Okay? So the thing to notice here, so the first thing is that you basically have this subquery which is selecting, it's using a tuple variable from the outside. This tuple variable is B1 and then it's using it within the subquery, right? So it's taking B1, reusing it within the subquery, and the way it's reusing it is you select star, you're assuming it to be a constant. B1 is assumed to be a constant, or B1 is assumed to be a constant tuple, and you select star from beers where the manufacturer is equal to B1.manufacturer and the name is not equal to B1.name. Okay, so so notice that the reason why I'm renaming this is because I can reuse it inside the subquery, right? So if I didn't want to reuse the values of this external relation within the subquery, I don't need to rename it. The main reason that I'm renaming it is so that I can use it within the subquery, right? So I can refer to the manufacturer and the name of the beer that I was talking about outside. All right, so basically I start with a set of beers indexed by the tuple variable B1, and then I take this tuple variable B1 and then I check whether I'm implicitly running another query to check this. Check whether there are any other beers by the same manufacturer that don't have the same name, right? So that's what this internal subquery is doing. So you're doing select star from beers where the manufacturer is B1.manufacturer, but the name is not equal to B1.name. If there were any such tuples, then my overall where condition evaluates to false, right? Because I'm checking the not exists condition. Okay? So this is not the interesting thing about, or the way this subquery is not trivial is because of this B1 tuple variable and the fact that B1 is being reused within the subquery. So far the examples that we've seen don't reuse the tuples from the outside inside. So the subquery is evaluated essentially independently of what is happening outside. In this case, that is not true. We are reusing B1 within the subquery. And in order to be able to use B1 within the subquery, I have to give it a new name, which is B1, right? Because otherwise, if I didn't give it a name B1, when I'm in the subquery, I'm confused about whether manufacturer refers to the external one or the internal one. And similarly with name. And as it turns out, at least the convention for SQL is that the closest scope defines the meaning of the variable. So when you list manufacturer and name, they are associated with the closest scope, which is the closest from clause, not the from clause outside, even if you are not listed this B1. Okay? Is this clear? Any questions about this? So like I said, the scope rule is that these attributes refer to the closest nested from with a relation having that attribute as opposed to the external from. So manufacturer here is associated with this relation, name here associated with this relation. So that's how I can disambiguate the meaning of these attributes. Once again, we were talking about why the not exists operator is actually useful. The not exists operator operates on a set of tuples and then checks whether that set of tuples is not empty, right? So that's essentially what is going on here. Like I said, the only interesting thing is that you're reusing this variable B1 within this query. This is an example of a correlated subquery. Okay, so since you're reusing a tuple variable inside, for this you can go see more examples and read more about it in the textbook. Okay, so we talked about exists, we talked about in, and we talked about a single value. Now we are coming to the operator any. So the any operator basically says this evaluates to true. So this is basically X operator any. So let's do this in this way. X operator any in parentheses relation basically means that, so this is a Boolean operator. This is true if X op T is true for any T in relation. Okay, so if X operator T is true for any T in relation, then this condition evaluates to true. So in our example, we had X equals any. If you have X equals any in this relation, that is a Boolean condition that evaluates to true if X equals at least one tuple in that relation. Okay, so if X equals at least one tuple in that relation, that will evaluate to true. And similarly, equals can be replaced by any other comparison operator. If X is greater than or equal to any in this relation, which means it means that X is greater than or equal to at least one tuple in the relation. Okay, and for this to make sense, for greater than or equal to make sense, these tuples must have a single component. It can't have multiple attributes, because otherwise it wouldn't have it wouldn't make any sense to do this comparison operator. Okay, so once again, this is the any operator is used as a Boolean condition, which is as some x operator any and then a relation. And this evaluates it true if x operator t is true for any tuple within the relation. Okay, so that's any. Let's talk about all before looking at an example. So the all operator is true if the condition is satisfied for all of the tuples in that relation. So once again, it's x op all and then relation. And this is true if x operator t is true for all or for all t in relation. Okay, so as an example of that, if x not equal to all of relation, this is true if and only if for every tuple t in the relation x is not equal to t. In other words, x is not a member of the relation. And like the any operator or any keyword, this operator can be replaced by any other comparison operator. So if you have x is greater than or equal to all relation, then that means that x is larger than every tuple in the relation. Okay, so it's pretty intuitive. It's not very surprising. Yes?
So this is the nautical sign the SQL?
Yeah, or you can say not, I mean, you can also do not of blah. Okay? Sorry, not of x equals something, right? You got that. So this is an example where we use the all condition. Let's say I have a relation cells and I want to find the beer sold at the highest price. Basically, I can do this as follows. So I have select beer from cells where price is greater than or equal to all other prices. Okay, so greater than or equal to all of select price from cells. So implicitly, I'm saying that the price should be greater than or equal to every single one of the tuples in this internal relation, which is select price from cells. Okay, so the price from the outer cells must not be less than any price within the internal cells. Okay, and why do we need this greater than or equal to and not greater than? Why do we need the greater than or equal to and not greater than? Yep.
Because if it was only greater than, you wouldn't get anything back.
Correct. So if it was only greater than, you wouldn't get anything back, right? So the price that you're trying to select, the maximum price, is also part of cells, and therefore if you just did the greater than, it's true that there is no price that meets that condition, because for a given price x, x is also present in the cells relation, and therefore you have to add the equality clause if you want to select the maximum. You can't have it just be the greater than. Okay. All right. So the maybe the last topic of the basic select from where syntax is the topic of bags. So we talked about bag algebra earlier as a contrast to set-oriented relational algebra, with the following sort of rules. In the union case, you add the number of occurrences. In the difference case, you subtract the number of occurrences. In the intersection case, you take the minimum of the two numbers of occurrences, while in the select, project, and Cartesian product cases or joint cases, you preserve the number of occurrences. You don't do any duplicate elimination. Okay, so that was bag algebra. Now, how does that translate to SQL? So the select from where portion uses bag semantics like we had discussed earlier. So the select from where statement, at least the selection, projection, and the Cartesian product preserve the number of occurrences. This is done for efficiency purposes like we discussed in the bag algebra case. Okay, and then let's talk about union. We have not even discussed what union, intersection, and difference actually look like in SQL. The way to do this is to simply use a keyword union, intersect, or except. And then you would have two subqueries. Okay, so you have subquery, union, subquery, subquery, intersect, subquery, subquery, except subquery. Okay, so this is the difference. The last one is the difference. Now, how do these operations work? Okay. Or rather, I guess I'm doing an example before I describe how they work. So let's say I have this relation likes, which contains customer and beer, sells, which contains bar, beer, and price, and frequents, which contains customer and bar. And I want to find the customers and beers such that the customer likes a beer and the customer frequents at least one bar that sells a beer. Okay? So in order to do this, I could think about this in two parts. The first part is with the customer liking the beer, and the second part being the customer frequents at least one bar that sells a beer. And I can think of these as two separate queries. The first query only touches the likes relation, and the second query touches the sells and the frequents relation. Okay? And let's see how we might want to use, for instance, the intersect operator to do this. So the first query is simply select star from likes. So these are just the tuples from likes. And I am intersecting this with select customer comma beer from sells comma frequents, where frequents.bar is equal to sells.bar. This is nothing but a natural join between frequents and sells. Okay, so this is nothing but a natural join between frequents and sells, and here I'm trying to find the customer beer pair such that the customer frequents a bar that sells a beer, and I'm intersecting that with the customer beer pairs from likes. Okay, so this is a use of the intersect operator. Now, let's talk about semantics. So even though the select from where part uses bag semantics, the default for all of these set operations is actually the set semantics. Okay, so it's a little confusing here. So the select from where is using bag semantics because this is efficient, but the set operations uses the set semantics. Okay, and in some sense, what does set semantics mean? This means that as and when every operation is performed, you are removing duplicates. Okay, so you don't keep duplicates around, you eliminate the duplicates. And the reason for this is efficiency and consistency. Okay, so for the projection, selection, and so on, it's easier to avoid doing elimination of duplicates. You just want to work tuple at a time. This is more efficient. On the other hand, when you're doing intersection or difference, it is most efficient to try to sort the relations first so that you can try to count the number of copies of each tuple in the two relations. Okay, so at that point, you might as well go ahead and eliminate the duplicates anyway. Even though the union operator is actually simpler, you simply need to add the two relations to each other, and therefore you don't need to do any sorting. It's actually lumped in with intersection and difference because of consistency purposes. It's also a set-oriented operation, and therefore we treat it like the other set-oriented operations which return sets. Okay, so it doesn't return bags. On the other hand, just the select from where is still going to return you a bag. Okay, it's not going to eliminate any duplicates. On the other hand, if you don't want this to happen, you can actually force different behavior. You can force the result to be a set by saying select distinct. So select distinct actually forces you to do duplicate elimination at the end of your operation. So it will only return the unique tuples from your query. or in the intersection or union or difference case, you can force the result to be a bag as opposed to a set by using the all operation and then saying union all or the other set operations with all following. Okay, so you can override the basic behavior by using either the distinct keyword or the all keyword. So as an example of its use, let's say I have a relation cells with bar, beer, and price, and I want to find the different prices that are charged for beers. I can use the distinct keyword by saying select distinct price from cells. Without distinct, each price would be listed as many times as there were bar, beer pairs with that price. So if $10 is, or whatever, let's say $5 is a very common price for a beer, that would be listed as many times as there are bar, beer pairs with that price. And so often distinct is useful to reduce, collapse these tuples down and only give you the distinct values. Okay? All right, so any questions about the select from where subqueries in any all nested subqueries with correlated attributes, the distinct union, any of this stuff? Any questions about this, because I'm switching over to aggregation? Is all of this good? Okay, all right. So let me switch over to aggregation. Cool. So we are now going to be studying something that we didn't study in relational algebra. These are sort of more complex constructs that are not part of relational algebra. Okay, so let's start with aggregation. So I can the simplest way of using aggregation is to just basically use an aggregation operation within the select clause, and I get an aggregated result. Okay, so I can use the sum, average, count, min, and max, and I can apply that to a column in the select clause, and I immediately produce an aggregation on that column. Count star is a special one. Count star counts the number of tuples. For the other ones, it doesn't make sense to apply aggregation to more than one attribute at a time. So sum, average, min, max, you don't want to apply it to multiple attributes at a time. You only want to apply it to one attribute. Count you can apply to all attributes essentially, or star. Okay, so count star is a convenience that counts the number of tuples. So this is a simple example. Here I want to find the average price of bud. So I would just say select average price from cells where beer is equal to bud. Okay, so this is a simple example of aggregation. If I want to count the number of bars selling bud, I would simply do select count star from cells where beer is equal to bud. Okay, so count star once again counts the number of tuples. Okay, so remember the way to think about both this query and the next one is you start from the cells guy, you loop over all of the tuples, you throw away those that don't satisfy the where clause, and then you finally compute the average of price. Here once again you start from all of the tuples in cells, you throw away all of the tuples that don't satisfy beer is equal to bud, and then from the remaining tuples you count their number, you return that as the output. Questions about this? Right? So in some cases where you may have values being repeated, you might want to use the distinct keyword once again, and turns out this distinct keyword can be used within an aggregation. And so one example of how you might use it is to say select count distinct price from cells where beer is equal to bud. So basically you're counting the number of distinct prices at which bud is being sold. Okay, so if there are 3 different prices at which bud is being sold, this would return 3. Okay, so the distinct price basically forces the duplicates to be eliminated before you apply the aggregation. So that's one way of thinking about what the distinct keyword does in this case. So minor annoyance about aggregation is how you deal with nulls. Nulls don't contribute to aggregation. Okay, so it doesn't contribute to a sum, average, or a count, and can never be the minimum or the maximum of a column. On the other hand, if there are no non-null values in a column, then the result of the aggregation is null. Okay, so here's an example. So if I did select count star from cells where beer is equal to bud, this is the first one is going to return the total count of the number of tuples. So total number of tuples where beer is equal to bud. Okay, on the other hand, this is going to be the total number of tuples where beer is equal to bud and price is not null. If price is null, it would not contribute to the count. Okay, so it would only contribute to the count if price is not null. Okay, so you have to be a little careful about what you want as part of your aggregation. Is this good? Any doubts? Alrighty. So a common or a convenient way of using aggregation is when combined with a grouping criteria. So you can follow a select from where expression or a query with a group by statement which allows you to group these attributes in various ways and then apply an aggregation per group, if you will. Okay, so the relation that results from the select from where is grouped according to the values of the group by attributes, and any aggregation is applied only within each group. So here's a useful case. So let's say I have my cells relation with bar, beer, and price, and I want to find the average price for each beer. Okay. Another real world example is I want to find the average GPA of undergrads in each department. Right. So this is a real world example of what I might want to do. Maybe I don't want to compute the average prices of beers, but I might want to do that with student data. Okay. So when I'm doing this, the way I would do this is to start with the cells relation once again. So that's the relation that I'm operating on. I'm grouping by the beer. So I'm implicitly saying, hey, this is my cells relation. Let's take all of the tuples corresponding to one beer and then operate on them, and then all of the tuples corresponding to the other beer and operate on them, all of the tuples corresponding to the third beer and operate on them. And so those form your groups. For each of these groups, I am going to compute the average price. Okay, so for each of these groups, so this is beer 1, beer 2, and beer 3. And so I will compute the average price of beer 1, average price of beer 2, and then so you will list beer 1, comma, average price of beer 1, and then beer 2, and average price of beer 2, and so on. Okay, so the way to visualize this is you take this overall relation cells you identify the groups of tuples corresponding to each group by value. So these are each distinct beer, and then you apply some aggregation on that, and the aggregation here is you're identifying the average price for each of those beers. So this is another example. Here I am trying to, from the cells in the frequency relation, which is a bar, beer, and price for cells, and frequency, which is drinker and bar, I want to find for each drinker the average price of bud at the bars they frequent. So since I say for each drinker, that should be an immediate cue that we are doing a grouping on the drinkers, and I want to find the average price of bud. Okay? So how do we go about doing this? So once again, I'm starting from the frequency and the cells relation. These are listed in my from clause. I want to focus on the bud tuples. So I immediately apply this beer is equal to bud condition. So I eliminate all of the tuples that don't satisfy that condition. And then I have this frequency.bar is equal to cells.bar, which is implicitly doing an equijoin between these two relations of frequency and cells. So I've computed combinations of frequency and cells for the bud selling bars. Okay, so that's what I've done with the from and where. Then I'm grouping by drinker. Okay, so I'm taking the result, and then I'm categorizing it into various groups, one group for drinker 1, one for drinker 2, and so on. And for each of those groups, G1, G2, G3, I'm going to then compute the average price, and then have that be part of the output. All right? So, so if I'm using an aggregation, then we have some rules of thumb on how you can use an aggregation. Basically, every element of the eventual select clause in my aggregation must be either something that's being aggregated or something that's being grouped by. Okay? So if it's something that is neither aggregated nor grouped by, that is a problem, because those attributes can take on multiple values. Right? If you're grouping by that attribute, then you know that for a group of tuples corresponding to a single drinker, there's only one drinker in all of those tuples. Right? And if you're aggregating on that, again, you're collapsing all of those values down to a single value. So it's, again, a single value. But if there's another attribute that you're not applying anything on and you're not grouping on, that is a problem, because you don't know which value to display. Okay? So let's say you had a drinker, price, and I don't know, what would be another interesting attribute to use within this? Any suggestions? Let's say phone numbers. Okay, so this drinker buys beer at various prices and has various phone numbers. Okay, so if I am doing, and let's call this the drink relation, or okay, so if I did select drinker, average price, and then phone number from drink, where let's skip the where because I don't need a where in this case, and then group by drinker. This does not work, and the reason why this does not work is because phone number is an attribute that is neither being grouped by, so it's not listed in this clause, nor are you applying an aggregation on it. Right? So since this query implicitly is returning one tuple corresponding to each drinker, how do you collapse the set of phone numbers into a single phone number? You haven't prescribed a way to do that, and because of that, this is an error. Okay? This does not work. So you either need to have every attribute being aggregated, or it must be an attribute in the group by list. If, on the other hand, you don't list it as part of your output, that's totally fine because you're not doing anything to it. Okay, so you can have attributes that are being grouped by, attributes that are being aggregated. Those are the only things that can be part of your select clause. Okay, so why don't I stop here and see if you have any questions, because this is the last class before the midterm. So aggregation is not going to show up in the midterm, so you don't need to worry about that, but everything up until that point will be covered. There was some confusion about the cheat sheet. I may have announced something incorrectly at the start of the class or the start of the course. But the cheat sheet will be allowed for the second midterm, but not for the first midterm. The first midterm, we've designed it in such a way that you don't actually need a cheat sheet, or at least will not need a cheat sheet if you remember stuff. But it's not something we are not going to be asking you questions that are very, very let's call it, that are based on rote memorization. It's going to be more conceptual. So most of your time will be spent in doing rather than remembering. Okay, so hopefully that gives you some cues as to how it will look like. It's not going to be just list X, right? Tell me X, or tell me this concept that we covered in class. So a cheat sheet is not going to help you as much. So which is why we don't have it, and there's not that much complicated syntax that you've studied so far. It's relatively straightforward syntax, which is why we are not allowing a cheat sheet for this one. But for the final, we will allow a cheat sheet, or a second midterm, we will allow for a cheat sheet. Yes?
The material is like up to the SQL thing where
So not this set of slides. So not the previous, everything in the previous set of slides.
Select from where?
Huh?
I mean, the slice of operation of select from where?
Yes, so the select from where, along with subqueries, along with the set-oriented operations, all of that stuff, not the aggregation. Yeah.
Are we going to know the answers from homework 2 before the midterm?
Yes. Yeah. Homework 2 most likely will not be graded before the midterm, but we will post the answers, well, hopefully as soon as, so it's due tonight, right? So we'll try to post them before the end of the week for sure. Anything else? So we will send you a note about this, but for the midterm, try to come in advance. Don't. So we will start promptly at 8, and you don't want to be late. So set your alarms and so on. Try to get here by 7:45 if you can, so that you are well settled in, and we can brief you on the instructions before you start. Bring your, this is probably familiar to you from your other class, but bring some identification. So bring your iCard or something. And that should be it, I think. Yes?
How's the exam formatted exactly?
It should be very similar to the previous year's midterm. So you can imagine some short answer questions, some, so basically covering the same sorts of things, same kinds of concepts. So you look at the previous midterm and you'll get a pretty good idea. So some short stuff, some more long answer, more derivation oriented questions. So it'll be a mix of those sorts of.
And that's on the wiki? The previous materials?
Yeah, it should be on the course website. Yeah. Anything else?
How long will the exam last?
It'll be an hour and 15, so the same time as a class. Okay, so but it looks like there's no class immediately following, so that'll give us some breathing room if I want to give you a little bit more extra time. All right? Okay? See you on Monday. Yes.